right, guys, welcome back. We're gonna do something a little different today. We're gonna do a warm-up for 5-3. And this is just a review from a lot of stuff, that having to do with the unit circle. And we're gonna need to know this today to be successful in lesson 5-3. So it's A through L here. And so I want you guys to pause the video, take as much time as you need to go through this warm-up and to remember, you're finding the angle, right, that makes the statement true. So you're finding the angle or angles. In this case, it says between 0 and 2 pi. Oops, excuse me. Between 0 and 2 pi. So what that means is that you don't have to worry about the restrictions. Okay, so here you're saying sine is 1/2, positive 1/2. So when is the y value positive? Here in quadrant 2, or that's quadrant 1, sorry. And here in quadrant 2. Okay, so then what angles are that? Well, if this is 1/2, that means that is the angle is pi over 6. And here it's 1/2, so that is 5 pi over 6. So those are my two answers. So that's what we're looking for here. What values, do I get for when cosine of theta is negative? And I guess I'll do one more for you. Okay, cosine is negative here in quadrant 2 and quadrant 3. Okay, so my x value is 1/2. So this right here is negative 1/2. And then this one is also negative 1/2. Okay. So what angles are those, right? So this one right here is 2 pi over 3. And then this is 3 pi over 3. And then this is 4 pi over 3. So that's what we're looking for. Okay. Go ahead, pause the video, do all of these, take your time, really try to focus on it because you will need to know how to do this to be successful in 5-3. So you really want to challenge yourself and practice it. So go ahead, hit pause, go through it, and then we'll go over it when you're done. Okay, so hopefully you've had time to go through this and try it out. We're going to just keep going. Sine is positive, so that's going to be quadrant 1 and quadrant 2. Okay, and my sine value is root 3 over 2. And then also in quadrant 2, I have another, I have another one that's root 3 over 2. And so the question is, what are those angles? And the first one is pi over 3. And the second one is 2 pi over 3. So just knowing the unit circle really well and figuring out those values. Let's look at D, E, and F. Cosine of theta is positive. So cosine is positive in quadrants 1 and 4. Okay, so my cosine value is 1/2. So this right here is 1/2 for that angle and also for this angle. So what are those angles? Well, the first one is pi over 3. And then you think there's 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. It's going to be the other one, just like that. E sine is negative. So that's going to be in quadrants 3 and 4. And sine is negative 1/2. So, oops. So it's here. And this is negative 1/2. And then it's here. Well, this is negative 1/2. So again, thinking about what those coordinates are. This is 6 pi over 6. So this guy right here is 7 pi over 6. And then if I keep going, I have 8 pi over 6, 9 pi over 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. That's what I'm looking for there. Okay, and then the last one is tangent is negative 1. So tangent is negative in quadrant 2. because my x is negative and my y is positive, so my answer will be negative. And then quadrant 4, because my x is positive and my y is negative, so I'll get negative. So what are those angles, right? So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And we're just going to keep cruising with it. GHI. Okay. The tangent here is positive. So it's either going to be in quadrant 1 or quadrant 3. And my tangent is positive here at this angle. So positive root 3 specifically here at this angle and this angle. So the first one there is pi over 3. And then this is 4 pi over 3. Oops. Or this is 3 pi over 3, 4 pi over 3 is the second one. Just like that. Okay, sine of theta is -1. So that happens here. There's only one, and it's 3 pi over 2. So in that case, there's only one angle. Here I have cosine of theta is negative. So it's going to be quadrant 2 or quadrant 3. And cosine is, I drew that really badly, but cosine is negative root 3 over 2. So negative root 3 over 2. That's here and here. So that first angle is 5 pi over 6. Then I have 6 pi over 6 and 7 pi over 6. We just gotta make sure we really know our angles. And then the last three. Cosine is negative, so again, that's going to be quadrant 2 and quadrant 3. And I have negative root 2 over 2, negative root 2 over 2, right? So what are those angles? So I have pi over 4, 2 pi over 4, 3 pi over 4 is the first one. Then I have 4 pi over 4, and then 5 pi over 4 is the second one. All right, sine of theta is 0. So that is this point here and this point here. So the first one is 0 and the second one is pi. The reason you do not write 2 pi, and let me kind of scroll up here, is because notice on my interval, I can have 0. It's right, it's less than or equal to 0, but I cannot be equal to 2 pi. So that's why we wrote 0 and pi instead of 0, pi, and 2 pi. Or just pi and 2 pi, okay? So that's the reason why we did that. And the last one, sine of theta, sine is positive, so it's going to be 1 and 2. Here's one angle and another angle, right, where this is root 2 over 2. And then this is root 2 over 2. So what angles are those? I have pi over 4. Then 2 pi over 4 is the vertical, so 3 pi over 4 is this second angle. So hopefully we're feeling good about that. If not, just make sure you reach out, maybe get some extra practice, things like that, because we're going to need to know how to do this fairly quickly in order to solve the other problems that we're going to look at today. Okay, so we're going to do 5.3 today, which is all about solving trig equations, okay? So our first standard is we're going to use standard algebraic techniques to solve trig equations. And then we're going to solve trig equations of the quadratic type. Hope you feel good on your factoring skills. And then we're going to solve trig equations involving multiple angles. So lots of fun stuff going on today, but really a lot of it is just trying to work our way backwards, just like what we did on the warm-up. Okay, so let's start with example 1. Let me see. Yeah, I can fit it all. Woohoo! Okay, so this says solve the equation 2 sine of x minus 1 equals 0. Use the graph as an aid to find all solutions. So first I'm going to start with solving this, okay? So 2 sine of x minus 1 equals 0. Well, I want to get the sine of x by itself, so I'm going to add 1. So just some basic solving here. Divide by 2. And I get sine of x equals 1/2. Well, this looks like a whole lot like our warm-up, right? So sine is positive, so it's going to be quadrants 1 and 2. And sine is 1/2. And then here, sine is 1/2. So I get x equals, this equation is pi over 6. Not equation, angle, sorry. And then this angle is 5 pi over 6. Gross. Okay, then it says use the graph as an aid to find all solutions. So those are 2 solutions, right? So that means here 1/2, 1, 2, 3, 4, 5. So right here, at 1/2, hopefully your straight line is better than my straight line. Okay, so this is 1/2. So I want to know when sine of x is 1/2. Well, it's 1/2 right here at pi over 6. It's also 1/2 here at 5 pi over 6. And that's the only time that it touches sine of x in that one period, right? This is one period. This is 2 pi right here. But then it also touches again here and here. So I guess now we ask ourselves, what is that distance? What is the distance to go all the way back around? So what's the distance from here to here? And it's essentially back in the same period. Well, again, it's 2 pi, right? It's the same spot on the unit circle. I've just gone all the way around. So here I'm adding 2 pi n. And then same thing here. What's the distance from 5 pi over 6 to this guy? And again, that's 2 pi. It's the same spot on the unit circle. I've just gone all the way around. So then this is also 2 pi n. And remember, n has to be an integer. So n basically tells you which period you're in. So, right, if n is 1, then it's pi over 6 plus 2 pi, which is right here. And this is 13 pi over 6. And then if n is 1, it's 5 pi over 6 plus 2 pi, which is here. What is that, 17. If n is 2, it'll be pi over 6 plus 4 pi, which is out here on the next one. And then if n is 2, it'll be 5 pi over 6 plus 4 pi, which is out here, right? So there's all these different solutions, and you can keep adding 2 pi and 2 pi and 2 pi, and it goes on forever, even if n is negative, right? If n is negative 1, then it'll be this guy. And then this guy. If n is negative 1, and then negative 2, and negative 3, and so on. So this is kind of what we're looking at, right? So we use what we just did on the warm-up to find the 2 initial values between 0 and 2 pi. And then we have to always add this either you have to add one period, whether one period is 2 pi, like with sine and cosine, or if one period is pi, like tangent and cotangent. Okay. I'd like you to try one. So I really do. I think you can do it. So I want you to try this guy. Solve the equation when cosine of x is 1. And then again, you can use the graph as an aid if you need to, but think about what we just did on the warm-up. And then when you're ready to go over it, hit play and we'll look at it. Okay, so let's look. I want to know when is cosine 1. So I can think about it a couple different ways. I can do the unit circle. Remember, cosine is your x value. So cosine is 1 here at 0. But if I make, right, I want to know all the times that cosine is 1. Why? Drawing a straight line apparently is really difficult for me today. Okay, so it's also 1 here, and it's also 1 here, and it's also 1 here, right? And what's that distance from one to the other? Well, in this case, it's 1 full period, which is 2 pi. So when is cosine of x 1? At 0 radians, so x is 0, plus every 2 pi. And since it can be 2 pi as many times to the right and as many times to the left, that's when we throw in the n. And I'm going to show you a shortcut. N, if I say n is in the set of a z and then double up the z like that, that's n is an integer. So this is the same as n is an integer. So like kind of like how we always say like x is in the set of all real numbers, now it's n is in the set of all integers. And that's what we're looking at. All right. So we're going to just keep practicing this, maybe without the graphs now. Okay. So it's just solving. It's just combining like terms and solving, okay? So example 2 says, find all solutions of sine of x plus square root of 2 equals negative sine of x in the interval 0 to 2 pi. So again, 0 is included, 2 pi is not. Okay, so I want to get all my sine of x's onto one side, all my numbers onto the other, right? So I'm going to go ahead and add sine of x to the other side, which gets me 2 sine of x plus the square root of 2 equals 0. Subtract root 2. So I have 2 sine of x equals negative root 2. Divide by 2, because I want that sine of x by itself, right? So I get sine of x equals negative root 2 over 2. And if you're a visual person like I am, I'm like, okay, sine is negative, so it's going to be in quadrant 3 and quadrant 4. Root 2 over 2 are those pi over 4s. So I get x is equal to, and this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and then 6 pi over 4, 7 pi over 4 is my second one. You don't have to draw it out, but sometimes maybe it helps visually. Okay, so I want you to go ahead and try this one. Same idea. Get all your signs onto one side, all your numbers on the other side, get that sine of x by itself. And I want you to find all the solutions of this in the interval from 0 to 2 pi. Pause the video, get it done, and then check your work by hitting play. Okay, hopefully we started by combining these signs. So if I subtract the 3 sine of x, I'm left with 2 sine of x equals the root 3. Divide both sides by 2, and I get sine of x is equal to root 3 over 2. So again, if I draw it, sine is positive, so it's going to be quadrant 1 and quadrant 2. And my x value is root 3 over 2, root 3 over 2. So then I get x is equal to pi over 3 and 2 pi over 3. Just like that. So it's just like the warm-up. You're just solving an equation and then doing what we did on the warm-up. Okay, let's look at another example. What happens if you have squares, right? How do you take the square root of that? So let's go ahead and solve this one. I want to get that tangent squared by itself. So I'm going to add 1. So I get 3 tangent squared equals 1. Divide by 3. So tangent squared x equals 1/3. And then when I take the square root, a couple things happen. 1, I get tangent of x on the left. And then plus or minus, that's always automatic, plus or minus, right? And then let's do this over here. So square root of 1 over 3. That is the same thing as the square root of 1 over the square root of 3. Well, the square root of 1 is just 1, so I have 1 over square root of 3. I am not allowed to have a square root on the bottom, so I have to multiply by root 3 over root 3. So I get root 3 over 3. So tangent of x is equal to plus or minus root 3 over 3. Okay, now since it's plus or minus, I'm going to probably end up doing this in a couple different colors. I need to know what angle gives me positive root 3 over 3. So let's do that in a blue. Okay, so tangent is positive here and here in quadrant 3. So 1 and 3, tangent is positive. What angle gives me this guy right here? And that is pi over 6. Now, if I add pi, right, what's the period of tangent? It's just pi, right? If I add pi to pi over 6, I get this. And then if I add pi again, I get this. And then I add pi again, I get here. So I can just say plus pi n. Okay, so hopefully that makes sense why I was able to do that. The other one then is negative root 3. Maybe I'll do it this way. This was positive root 3 over 3. This is negative root 3 over 3. And x equals, there we go. Okay, so negative root 3 over 3 is going to be here in quadrant 2 and here in quadrant 4. So then again, I can just keep adding pi and pi, right? But I have to know what this is. It's 5 pi over 6. Because I can just keep adding pi to go halfway around the circle, I can just say plus pi n. And then we have to remember that n has to be in the set of all integers. So this is what I'm looking for here. And the reason I have so many answers is because of the plus or minus. So really it was all of the tangents that equal root 3 over 3. Okay, I want you guys to try one now. You can do it. Solve this, and then don't forget your plus or minus when you take the square root. Do it and then hit play and we'll go over it. Okay guys, so hopefully you had time to try this. We're just solving it for cosine squared, so I'm going to add the 3 to the other side. Cosine squared of x equals 3. I'm going to divide by 4. Okay, and then I'm going to take the square root, which gets me cosine of x equals plus or minus. And again, I'm going to do the square root. So square root of 3 over 4 is equal to the square root of 3 over the square root of 4. I'm ahead of myself. The square root of 4, which gets me root 3 over 2. So I want to know plus or minus root 3 over 2 for my cosine. Okay, so again, with the positive root 3 over 2, we're going to have a certain value for x. And then for the negative root 3 over 2, we're going to have a certain value for x. So let's look. Okay, positive root 3 over 2 for cosine. Okay, cosine is positive in quadrants 1 and 4, right? So I'm actually just going to stay in purple here. So 1 cosine is root 3 over 2. So here and here, or when cosine is positive, right? This is root 3 over 2. This is, oops, I wrote it like sine. This is root 3 over 2. And then negative cosine is here in quadrant 2, in quadrant 3, and this is negative root 3 over 2. So this first angle, the very first one is pi over 6. And if I don't even really like that. So if I add, let's see, pi over 6, if I add pi, I'm going to get here. Is that still an answer? Yeah. And then if I add pi again, I get here. Is that still an answer? Yeah. Right, if I add pi, right? So I can just do pi n. Same thing here. This guy is 5 pi over 6. And if I add pi, I'm going to get down here at 11 pi over 6. And then if I add pi again, I get 5 pi over 6. And I add pi again and again, right? So I can just keep adding pi. And then we just have to make sure that n is in the set of all integers. And there it is. Okay. Hopefully that makes sense. Just solving the equation and then doing what we did on the warm-up. Okay, the next type of problem that you might see is if you have to factor out a greatest common factor. So let's look here. I need to get everything onto one side before I can solve for it, okay? So I'm going to subtract this 2 cotangent. So I have cotangent of x, cosine squared of x. I just said I was going to subtract it, and then I didn't. Minus 2 cotangent of x equals 0. Okay, so then I have to ask myself, what is the greatest common factor? And I do have a cotangent in both, so I can take out a cotangent, which leaves me with a cosine squared minus 2. And then just like a zero product property, right? Imagine if I had like 4x and x plus 4. I don't want to do another 4. X plus 5, right? Equals 0. How would I solve that? I'd set 4x equal to 0, and I'd set x plus 5 equal to 0, and I would solve. It's exactly what I'm going to do here. Okay? So I'm going to set cotangent equal to 0, and solve, solve, solve. And then I'm going to set cosine squared of x minus 2 equal to 0, and solve, solve, solve. So let's do this one first. Cotangent is 0, which means that the y coordinate has to be 0. Sorry, the x coordinate has to be 0, right? Cotangent is equal to cosine over sine. So it has to be 0 over sine, right? So the cosine value has to be 0. Well, the cosine value is only 0 here at pi over 2 and here at 3 pi over 2. So here x is equal to, and I can say pi over 2 plus pi, plus pi, plus pi, right? So I can say plus pi n. And again, n has to be in the set of all real integers. So there's the first one. This looks real messy. Let me fix this. It looked like cursive or something. Pi n. Okay, the next one. Cosine squared of x equals 2. And take the square root. Cosine of x equals plus or minus the square root of 2. So if you were to when is my cosine square root of 2? Not square root of 2 over 2, just square root of 2. And here, this is not possible. You don't always have one that's not possible, but very frequently you have one that's not possible. So this is just not possible. So then your only answers would be pi over 2 plus pi n. Okay, I want you to try a factoring one. So here's this one for you to try. Get everything on the one side of the equal sign, take out your greatest common factor and solve, and then we'll go over it. Okay, so hopefully we started by moving that sign, or that 2 sine of x, over to the other side, just like so. My greatest common factor here is sine, so I'm going to take out a sine, which leaves me with sine of x minus 2. And I'm going to set both of these equal to 0 and solve. Okay, so the first one, what angles are sine of x 0? Remember, sine is your y coordinate. So right here is 0 and right here is 0. So x is equal to 0 radians plus, what do I have to do to get to the next one? Add pi, right? Plus pi. N. When n is in the set of all real, or all integers. So just keep adding pi. Okay, for the second one, I'm going to do sine of x equals 2. When is my angle, or the coordinate of sine ever 2? And it's never, so this one is also not possible. So these are just all different types of problems that you will see. And you just have to be able to recognize, oh, it has a greatest common factor, or, you know, oh, it's just an equation I can solve, or, oh, I have to factor it, or whatever, right? This is just exposing you to multiple types of problems. The next type of problem is factoring a quadratic. So how I kind of do this is, if I have a sine squared and a sine and then a term with no trig function in it, I look at it and I say, oh, that's like really similar to 2x squared minus 1x minus 1. Does that make sense? So instead of the sine, I'm like kind of switching sine squared of x just for x squared and sine of x just for x. Because this I can factor really easily, right? This gets me 2x plus 1, x minus 1 equals 0. So I know I can factor that really easily, and if you can't factor that really easily, you can always use x box, okay? But that gets me 2x squared minus 2x plus 1x, so that's the negative x, and then minus 1. So then what this really is that once I substitute the sign back in, it's 2 sine of x plus 1, and then sine of x minus 1 equals 0. Okay, so I just kind of think of it like this temporarily to help me factor it. And then I'm just going to set each of these equal to 0. Plus 1 equals 0. And then sine of x minus 1 equals 0. Okay, so I'm going to minus 1 and divide by 2, or I guess we can do it in separate steps. So 2 sine of x equals negative 1. So sine of, x equals negative 1 half. So then I'm going to go over here and draw it out. Sign is negative, so it's going to be here and here. So here x is equal to, this guy is 6 pi over 6, so 7 pi over 6. This angle is 11 pi over 6. And the reason I'm not doing it plus pi or anything like that is because of right here. It told me that it only wants on the interval from 0 to 2 pi. I can't keep going around and around and around the circle. I can only go around once. So what angles just in that first rotation meet the criteria? Okay. And then here I have sine of x equals 1. Remember, sine is my x value, or my y value, so when it's 1, it's here, right at 0, 1, which is pi over 2. So those are the 3 values that I am allowed to have. So, because it gives you the interval from 0 to 2 pi, you can't just keep adding pi over and over and over, or adding 2 pi over and over and over, okay? They only want the initial in the first rotation. All right, so another you try this quadratic, hit pause, try it, hit play when you're ready. Okay, so I'm gonna rewrite this with my x's, so 2x squared minus 3x plus 1 equals 0. Just because it helps me factor. So this factors into 2x minus 1, x minus 1. Okay, so then factored, this gives me 2 cosine minus 1, and then cosine minus, x minus 1 equals 0. So I just set them both equal to 0 themselves. So 2 cosine of x minus 1 equals 0. Then cosine minus 1 equals 0. So 2 cosine of x equals 1. So here cosine of x is 1/2. And then here cosine of x is 1. Okay, so again, I think it's helpful to draw it. Cosine is positive in 1 and 4. So cosine is 1/2 here and here. And it wants me in the interval from 0 to 2 pi, so I'm not going to be adding pi n or anything like that. So x is, this angle is pi over 3. This angle here is 3, 4, 5 pi over 3. So those are the two where cosine is equal to 1/2. Now I want, when is cosine 1? Remember, cosine is 1 on the x-coordinate, right? The x-coordinate is 1. So that's this point right here at 1, 0, which is 0 radians. And the reason we use 0 and not 2 pi, again, is because 0 is included, 2 pi is not. There we go. Hopefully just getting exposed to all these different types of problems is helpful. We have a couple more types of problems to expose you to, and then we're going to do one problem on our graphing calculator, and then we'll be done. Okay. So the next one here is functions of multiple angles. So this happens when you have a number in front of your variable or a number inside the trig function. Okay, so what happens is you're going to solve this like normal, right? So I'm going to have 2 cosine of 3t equals 1. So cosine of 3t, I'm going to put this in parentheses, equals 1/2. Okay, great. So what this means is, hey, cosine of some angle equals 1/2. Well, we can find that, right? If we draw it, cosine's positive, so it's going to be quadrants 1 and 4. Cosine is 1/2 here and here. So cosine is equal to 1/2 at pi over 3. We actually just did it, right? And 5 pi over 3. Sorry, my knee is like really uncomfortable, so I keep having to move the computer. Okay, so I know that whatever is inside this parentheses is equal to pi over 3 plus 2 pi n, right, because it doesn't have an interval, and 5 pi over 3 plus 2 pi n, because it doesn't have an interval. So in this case, what's in the parentheses is 3t. So this tells me that 3t has to be equal to pi over 3 plus 2 pi n, and 3t has to be equal to 5 pi over 3 plus 2 pi n, right? Because those are the two angles that cosine of some angle is 1/2. And these are the two angles that fit. But it's not just cosine of x, it's cosine of 3t. Okay, so now I have to solve this. So I'm going to divide by 3, divide by 3, divide by 3. Right? Everything has to divide by 3. So I get that the angles are pi over 9 plus 2 pi over 3 n. And then here, if I divide everything by 3, I get 5 pi over 9 plus 2 pi over 3 n. Again, where n is in the set of all integers. So it's just taking it one step further, okay? We know how to find the angle that makes that trig function true. The only difference is because it's a 3t instead of just a t, we then have to divide everything by 3 in order to make it work. Okay, I want you guys to try the next one, so go ahead and hit pause, give it a try, and then when you're ready, let's look at it. Okay, so same thing, I'm going to solve. This one's kind of already solved for, right? So I know that tangent of something equals root 3. So hopefully that makes sense, right? So here's my tangents. It's positive, so it's going to be either in quadrant 1 or quadrant 3. And at root 3, it's here and here. So the angles that have a tangent of root 3 are pi over 3 and 4 pi over 3. Does that make sense? So pi over 3 is just pi over 3 plus pi to get to 4 pi over 3, and then plus pi, plus pi, plus pi. So I can just say pi over 3 plus pi n. But because of this 2x is really what's in the parentheses, I have to set 2x equal to pi over 3 plus pi n. Then I have to divide by 2, divide by 2, divide by 2. And I get x is equal to pi over 6 plus pi over 2n. Oops, where n is in the set of all integers. That's really hard to draw on this keypad, apparently. It's a very, very similar idea. The only difference is because whatever's in the parentheses here, right, my question mark, because that's a 2x, I just have to set my answer equal to 2x and then just solve it just for x. Okay, I know this is a lot, just a couple more. Last example like this. Solve it. It's just a normal equation. We're going to solve. Same idea. I'm going to subtract 3. So I get 3 tangent of x over 2 equals negative 3. Divide. So I get tangent of, and remember, you can always write this x over 2 equals 1/2 x. So if that helps you, you can do that. It's up to you. The tangent of x over 2 equals -1. Right? So this is telling me like tangent of something equals -1. Well, if I draw it, tangent of -1 is here and here. So it's at 3 pi over 4 and 7 pi over 4. I'm blanking. Or really 3 pi over 4 plus pi, plus pi, plus pi, right? Because there's no interval here. They didn't tell me they just wanted it in the single rotation. They want all of the answers. So all of the answers are 3 pi over 4 plus pi n. But that's not equal to x, that's equal to x over 2. Okay, so I'm going to have to multiply everything by 2. So times 2, every single term gets multiplied by 2. The 2's cancel here, which is the whole point. Right, and I get x equals 6 pi over 4 plus 2 pi n. And then that reduces, and you bet your butt that you got to reduce it, right? So 3 pi over 2 plus 2 pi n, where n is in the set of all integers. So you're solving it just the same, you just might have to multiply or divide by something first. Okay, last one like this for you to try. Give it a shot, hit pause. It's very, very, very similar. And then when you're ready to review it, let's do it. Okay, so hopefully you had a chance to review it. Not, do it now, right? But I'm going to solve this for tangent. So tangent of x over 2 equals 1. So, right, tangent of something equals 1. Well, if I draw it, 1 is here and here. So that's pi over 4 and 3 pi over, sorry, not 3 pi over 4, 5 pi over 4. Or more accurately, pi over 4 plus pi, plus pi, plus pi. So I have pi over 4 plus pi n. But that doesn't equal x, that equals x over 2. So again, I'm going to have to multiply by 2, multiply by 2, multiply by 2. And I get x is equal to 2 pi over 4 plus 2 pi n. So x is equal to pi over 2 plus 2 pi n, where n is in the set of all integers. So I think the biggest thing is if they give you an interval, like, oh, what's your answers between 0 and 2 pi? You do not need to do this plus 2 pi or plus pi, okay? If it wants you to just solve it or find all the solutions, then you will have to do that. So it's just really important that we pay attention to what the question is asking us to do. Okay? All right, last type of problem is approximating solutions with our graphing calculator. So that now would be the time to get out your graphing calculator if you don't have that done already. And then the biggest thing, biggest thing when you are doing this, look at your interval, 0 to pi or negative pi to pi. This is not given in degrees, it is given in radians. You need to make sure that your calculator is in radians. So important. You need to make sure that your calculator is in radians. So go ahead and get your graphing calculator up, and then I'll show you what to do from there. Okay, so let's look at what it's asking me to find here. So it says approximate the solution of x equals 2 sine of x. So what it wants is, hey, I want you to graph x, right, which we know is just a horizontal line, or a perfectly diagonal line. And I want to know, when does the graph x cross the graph 2 sine of x? So I'm going to have to graph these separately. Okay, so I'm going to start with that. So clear out anything that you have. Make sure you're in radians. Okay, so I want to know, when does the graph x cross the graph 2 sine of x? Okay, now let's look, because if I just graph it, let me go back. If I just graph it here, I got nothing. It does not look right, right? Even if you are like in your standard, there's x, it's like okay, but I want to know like these points right here. So I'm going to modify this a little bit. Okay, so I'm going to change the window because I only want the interval from negative pi to pi. So that means under window, I want my x minimum. I want the furthest to the left it goes to be negative pi. And then I want my x max to be pi. And then what would really help me too is if the scale actually, because right now the scale is set to go like 1, 2, 3, right? Each tick mark is 1, 2, 3. I don't want that. I want each tick mark to be something in radians, so I'm going to do pi over 4. Okay, and then what's the highest this graph goes, right? Well, the amplitude for sine is 2. So my y minimum, I'm going to want it to be negative 2. And then my y maximum, I'm probably going to want it to be positive 2. And then the y scale can just be 1, right? 1, 2. I think that's okay. So let's go in our window and kind of adjust this so that it looks a little bit better. So I want my x minimum to be negative pi. And I want my x maximum to be pi. And I want my scale to be pi over 4. Then I want my y minimum to be negative 2, my y maximum to be 2. Otherwise, I'm just going to be seeing a lot of space that I don't care about. And I think the y scale is 1 is fine. So now let's look. So there's y equals 1, or y equals x. And there's my sine graph. And so I want to know, when do these intersect, right? So I'm going to go to second, trace. And I'm going to go number 5, intersect. I want to know, when do these two graphs intersect? The first graph is x. So, and your calculator needs help figuring out which point of intersection do you want, right? We can clearly see 3 points of intersection. And so your calculator can't do all 3 at once. You have to do them individually. So I'm going to go down here. And I'm going to say, yes, this blue line is the first curve, right? This is the first equation. Yes. And then it says, is this the second equation? And I say, why, yes, it is. Then on a guess, I would get kind of near, because that's you telling your calculator, I want you to find this point of intersection. So I hit enter. And I have negative 1.895. So x is approximately negative 1.895. So there's one answer. Now I have to do all of that again, right? So I'm going to go second, trace, number 5, intersect. And it says, is this the right line? And I say yes. And it says, is this the right line? I say yes. And then my guess, I'm going to get kind of close. And 0 is the next one. So 0. And then I'm going to do it again for this guy. Second, trace. Number 5 is intersect. Again, now I'm going to be interested in this one. So the blue is the correct one for the first one. The red is the correct one for the second one. It's close enough on a guess. Hit enter. Now it's positive 1.895. 1.895. So those are the point of intersection. So really it's looking at it and determining what I want my x scale to be, what I x min, x max, y min, y max, stuff like that. So I want you guys to try the next one. It's very similar. Oops, lost you. And go ahead and graph this in your graphing calculator. We want the interval negative pi to pi, so that will stay the same. Your y min and max might change. So go ahead and hit pause. Do this on your graphing calculator, see what you come up with, and check your answers. Okay, so these are the only changes that we made here. Here, y1 is 4 cosine of x, y2 is x. You could have kept y1 as x and then made y2 4 cosine of x. It doesn't matter. Okay, and then because of that 4, my amplitude is now 4, so that means my y min and my y max are going to have to be negative 4 and 4. So I've gone to my calculator, I've plugged in my two equations, I've adjusted my window, so I'm ready to graph it. So there's my cosine graph, and there's the graph y equals x. And so here I can clearly see that it crosses twice in this interval from negative pi to pi. So I'm going to do my second trace, intersect. It says, is the blue line correct? And I say yes, but I want it down here. So yes, yes, it's good enough, yes. And I have negative 2.133 is one of my answers. So negative 2.133, comma. Now we have to do the work to find the second one. So second quick. Oops, second trace, intersect. Now I'm going to go up here. So someone there, yes, yes. And then yes on the guess, and I have 1.252 on the second one. 1.252. And again, I used approximate because I am rounding those answers. They're not exact. Whew, okay, hopefully that makes sense, you guys. I know that that was a long one. If you have any questions at all, make sure you reach out and ask for help, and we'll see you guys soon.